Every year, humans put about 8.5 gigatons of CO2 into the atmosphere, but atmospheric CO2 levels only increase 5 gigatons yearly. The other 3.5 gigatons are added to biological processes by photosynthetic organisms. Our basic goal is to increase this amount of CO2 that is used by photosynthetic organisms by increasing the photosynthetic organisms themselves, and to decrease ocean acidification using the ocean itself. Enter super seaweed. This entails the farming and placement of large amounts of seaweed in marine areas. This seaweed could be modified to grow very dense or tall in order to convert and store large amounts of atmospheric carbon. This seaweed farming would be done away from marine protected areas and in higher latitudes so that it does not interfere with coral reefs. This all means that the seaweed used would have to be cold resistant, be able to respond to changing levels of light throughout the year, and be sturdy enough to maintain a large size. Besides slowing the rate that carbon is added to the ocean and atmosphere, these seaweed areas could provide nurseries for marine life and even flood protection if it is close enough to coastlines. Even though this seaweed would be grown away from reefs and marine protected areas, it still does run the risk of choking out already present organisms either by blocking light or by decaying and creating dead zones. To lessen the chance of this, once it grows tall enough, some seaweed could even be transplanted to deeper parts of the ocean so that it may still reach sunlight and grow even higher. Alternatively, instead of being transplanted, the seaweed could be put into livestock feed or used as fertilizer, as opposed to petroleum-based alternatives, or biofuel. This last option still puts carbon into the atmosphere, but at a carbon net of essentially zero, since it is being cycled back into plants over and over. The cost of this would be relatively high, especially if transplantation is the primary fate of the seaweed. But costs can also be offset directly by selling seaweed for human or livestock consumption, and indirectly with decreasing the cost of damages caused by floods. And since seaweed aquaculture is already an established practice, scaling it up would be less expensive than creating new technologies to solve or decrease the same problem. This would not solve all our carbon problems, only the rate at which carbon is added to the atmosphere. But it would be an important intermediate step to fund as we wait for future technology, such as large-scale adoption of non-fossil fuels, to emerge.